Hey guys, welcome back. I'm gonna go ahead and do another graph analysis question. This is from 2019, so this is from last year. So just kind of give you an idea of how the questions are kind of evolving and what they're looking for and what they're asking. Okay, and I'm gonna do another one because this is the last graph analysis, and then I want to show you another one that's kind of out of the blue. That's not like we've done before. Also from 2019. But let's go ahead and look at this one. It says the continuous function f is defined on the closed interval between -6 and 5. The figure above shows a portion of the graph of f, okay, consisting of two line segments and a quarter circle, so that's important, centered at the point 5 comma 3. So 5 comma 3, 5, 1 is over here. So that's the center of that circle, okay? It's known that the point 3 comma 3 minus radical 5 is on the graph of f, okay? All right, so they give us a graph of f, and then they tell us, okay, it's interesting because this is not a derivative, is it? Okay, so let's look at part A. And it said if the integral from -6 to 5 of f of x dx equals 7, find the value of the integral from -6 to -2 of f of x dx. Show the work that leads to your answer. And right off the bat, you're thinking like, man, what do I do? Okay, so I think the best way to approach this one is because a lot of us are visual, and I want to show you guys something, okay? So let me tell you something, let me show you guys something. Let me draw this right here, okay? And then let's say, okay, that's my x and y axis, that's 0. So if I know from -6 to 5, the area is 7. So all right, let's say -6 is over here and +5 is over here. All right, do that, do that. All right, and then so I know, so I don't know what this function is, just let's do that. So I know that the area underneath this curve between here and here is 7. Okay, that guy is 7 all the way from here to here. All right, okay, then it says find the value from -6 to -2. All right, so from -6 to -2 is right here. So this is what I got to find out. Okay, so all of a sudden it kind of makes it a bit more clear, huh? And look at, they give me from -2 to 5, don't they? So this I'm able to figure out. Okay, I'll be able to figure this out. Okay, area underneath the curve. So how am I going to figure this out? So now it's starting to become a little bit more clear, isn't it? So what you're going to do is you're going to apply your properties of integrals. So if you think about it, if I do this part, or if I do the whole thing, right? If I do the whole thing, take away this part, I'm going to be left with this part. Okay, so we'll just go ahead and do it step by step just so you guys can know, and then you guys can, fix it however you want. But so basically we're doing from -6 to -2, and I'll just put it up here. So the integral from -6 to -2 of f of x dx plus the integral from -2 to 5 of f of x dx. Okay, that tells me, that implies that is 7. So now I got to solve for this guy. So that means that the integral from -6 to -2 of f of x dx is equal to 7 minus the integral from -2 to 5 of f of x dx. But see, what did I do? I took something that's very abstract, and then I created a diagram for myself so I can see like, oh, okay, that makes sense now. And now I can approach it. So I know this is 7, so now I got to find the integral from here to here. So I can do that. Now I want you guys to see a couple of things here. And because we got to do the area underneath the curve, right? So this guy above here is positive, and then this guy's negative, and then this guy's positive. Now if you notice something here, and this is important just for sake of time, right? If you notice here, this area right here is actually going to be equal to this area right here. You see how they match up? They have the same area. And then these little guys right here, these two right here, see, they also match up. Like that. See, so these guys are matching up. So these become zeros. Okay, maybe I should have done it a different color. Let me do black here, guys. Sorry. So you see that these guys are matching up, right? So that's positive, that's negative, that cancels out. That's positive, and negative, that cancels out. And I do that just because, for sake of time, especially on the test, it's timed, right? But hey, if that's confusing, just do the area above, positive, the area below, negative, and then just do that. Okay, but I know intuitively this is going to cancel out, this is going to cancel out. So now what do? Now I got to find the area of everything else, all of this stuff. Well, let's see, how am I going to do that? Well, we're going to start breaking it apart. If you notice, this guy right here, okay, it's like a trapezoid, but I'm going to make a square, I'm sorry. So the area of this guy is 1 times 1, which is 1. And then the area of this triangle, it's 1 times 2. 1 times 2 is 2, but a half of 2 is 1 because it's a triangle. Okay, so you have that. So this area here is 2. Well, how do I find this curve here? And notice what they're going to have us do. Okay, if I take the area of this whole square right here, okay, this whole guy right here, okay, this guy right here, if I take the whole thing and then I take away or I subtract this quarter circle, I'm going to be left with the area here. And that's what they want us to do. So you see how the questions are kind of evolving a bit into more conceptual understanding there. Okay, but that's not too hard, not too difficult. So here I know it's 2. So let me see, this is 1, 2, 3. 3 times 3, that's 9. So that's going to be the area. I'll just do it right here, 9. Okay, the whole thing is 9. Okay, the whole thing is that I'm going to subtract this quarter circle minus, okay, well, pi r squared, right? Pi r squared divided by 4 because it's a quarter circle. The radius is 3. Okay, so now that means it's going to have 9 minus 9 pi over 4. Cool. So now, what do I have? I have these two little guys, okay, and then I did the whole thing minus the quarter circle. The whole thing minus the quarter circle ends up with this guy right here. So then we'll have 2 plus this is going to give me my area. So 2 plus this part, okay. So then I have 7 minus, put that in brackets, and then 2, these 2, plus, why is it plus? Because it's above the x-axis, remember? And then you have 9 minus 9 pi over 4. Okay? Alright, so now just be careful with your steps, okay? Because remember, this negative is on the outside of the integral, so that's why I had to put my brackets there. 2 plus 9 is 11. So we have 7 minus 11 minus 9 pi over 4. And notice what I have to do. I have to distribute that negative. So 7 minus 11, that would be negative 4. And then negative times negative, that would be a positive 9 pi over 4. Okay. But you know what? If you want to leave it like this or like this, that should be perfectly acceptable. They'll give you the points. Okay, if you're scared you're going to make a mistake or whatnot. Because all of this is just what? Arithmetic. They're not going to test you on arithmetic. They're testing you on your calculus understanding. So don't be afraid, okay? All right. And I've heard the same thing from other teachers that actually grade the AP exam. So don't worry, guys. All right, part B. So all this is part A. And hopefully it makes sense. I'm sorry that it got kind of convoluted all here. So part A, I'm done. Part B, okay? Evaluate the integral from 3 to 5 of 2 times f prime of x. Well, how am I going to do that? See, this is the graph of f. This is f prime. Okay, well, how am I going to use u substitution? What am I going to do? Well, this little guy here kind of throws a wrench in it, right? So what do I do? Well, what you can do, guys, is break it apart. So what I'm going to do is I'm going to break apart this integral. So I can do the integral from 3 to 5 of f prime of x dx plus the integral from 3 to 5 of 4 dx. And you see how there's a 2 in the front? Normally I would put the 2 here, but I'm going to go ahead and take it out because it's a constant. I can do that. Okay. Now this guy here, I'm just going to do it the long way. Okay. Just nice and easy. The 4 becomes a 4x, right? Or 4x over 1. And then we go from 3 to 5, right? And then we do what? 4 times 5 minus 4 times 3, right? 4 times 5 is 20. 20 minus 12 is 8. Okay? That's the long way of doing it. But if you notice, if you understand that this is the horizontal distance x from 3 to 5, that's 2 units. And this is my vertical y value, so it's 2 times 4. So 2 times 4 is 8. And there it is. But it's okay. Just do it step by step the way you guys know how to do it. Okay? Don't change anything. Okay? If it doesn't make sense, do what you know. All right. So now what's the antiderivative of f prime of x? Okay, well, that is f of x. So we're doing our fundamental theorem here. So it would be top f5 minus f of 3. That's what we're doing there. That's all we're doing, our fundamental theorem. Okay, f of 5 minus f of 3. Okay, well, what is f of 5? Okay, so we go to our graph. That's our graph of f. At x equals 5, what's the y value? Oh, it's 0. Nice, beautiful. Minus. What's f of 3? Well, let's see. I get that little thing there. Remember they told us when x equals 3, the y value is 3 minus radical 5. So here I'm going to have 3. Okay. Let's put that parentheses because I'm subtracting minus parentheses 3 minus radical 5. Okay. And then of course I have that 2 on the front. All right. So now this is where it gets tricky, right? Because all these negatives. So negative 3 and then negative 10 negative becomes a positive. So 2, let's just leave that out there real quick. Negative 3, negative 10 negative is a positive, radical 5. All right. Okay. So then this becomes negative, what's that? Negative 6 plus 2 radical 5. And then negative 6 plus the 8, that's going to give me 2 plus 2 radical 5. Okay. Sorry, guys. So that's the part for part B. So what did I do? I used my properties of integrals to split it up. Why? Because I didn't know what this guy was. See, so I kind of simplified stuff for myself. Okay, and then I did the fundamental theorem. All right, so good question how they throw that in there. Part C. Okay, part C, it says the function g is given by this integral. Find the absolute, what? Maximum value of g on the interval from negative 2 to 5. All right, so they want the absolute minimum, maximum value. So as soon as I see maximum minimum, okay, what do I think about? I always start thinking about, okay, first derivative, set it equal to 0, get your critical points, your number line. Okay, so, okay, what's my function? My function, they tell me, oh, this is my function. So what do? I take the derivative, set it equal to 0. All right, so the derivative of this guy, remember the derivative cancels out the integral. So you're going to get f, right? This guy just goes in there, f of x. Boom, we're going to set that equal to 0. So basically, where's f of x equal to 0? Okay, well, I go to my graph of f. Where are my critical points? Where does f of x equal 0? Right there, right there, right there, okay? And so at x equals negative 1, 1/2, and 5. I don't really like it when they throw in those halves, but oh well. All right, let's go ahead and do that. So negative 1, 1/2, and 5. Okay, where are we going to put it into? We're going to put it into g prime, or which is f of x, right? G prime of x equals f of x. All right, so to the left of negative 1, what do you notice? Hey, the slopes are positive. There you go. Right? After negative 1, what? The slopes are what? They're all negative. Very good. And then after that, what? They're all positive. Good. And then what happens after 5? Well, we don't know because it ends. So what do you notice? Well, it goes up, then it goes down, then it goes up. Where do we have a possible max? Right here. There you go. There's a max. There's a relative max. Cool. But that's not what they're asking for. What are they asking for? The maximum value. So now you have to figure out, okay, not only the critical point value, you have to figure out this guy and this guy, the endpoints. So now you're going to go ahead and do g of what? You have to find g of negative 2, okay, you're going to have to find g of your critical point in the middle and g of -1. And you're going to have to find that other endpoint, g of +5. Okay, guys? All right, good. All right, so now what do I do? All right, so now we know g of -2. Well, how do I find that? Right? Remember, g of -2, what do they give me? They give me the derivative, right? Well, then how am I going to do that? Do they give us g of -2? No. So remember, hopefully I have enough room here. How do I find, and I'll just do it this way, okay? How do I find g from the graph of f, right? That's what they give me. Well, this is f, okay, which is the derivative. This is g prime. So if I take the integral of g prime, I'm going to get my g. Okay, so notice this is your derivative. If I take the antiderivative, then they'll be able to give me, I'll be able to get g of -2. All right. So then where do I go from? Well, they don't really give us an initial condition, so we'll start at -2. So we'll go from -2 and we're going to go to -2. Well, I really don't have to do much there to figure it out because the limits of integration don't change, so it's going to be 0. All right, so that one's done. All right, so the next one, we're going to go from, and I'm going to run out of room, and it's okay, -2 to -1 of g prime of x dx. Okay, so now I do my antiderivative, and I'm going to get g of -1 minus g of -2. All right, so let's rearrange it. I got to solve for g of -1. So g of -1 is equal to, take this guy to the left, becomes a positive. Okay, and then plus the integral from -2 to -1 of g prime of x dx. Okay, and what is g of -2? Well, that's 0. Plus, right, we just found it. And then what about from -2 to -1? Well, that's the area underneath the curve. So from -2 to -1, we found this guy out. That's 1/2. That's a positive 1/2. Okay, so then that means g of -1 is 1/2. Okay, now the last one I got to do is g of +5. And we do the same thing. Okay, and let me go ahead and do it just step by step so we don't get confused. Okay, so I'm going to go ahead and do the integral of g prime of x dx. And we're going to go from -2, because they don't give us an initial condition, but we know we're starting from -2. And then we're going to go to 5. Okay. And then we're going to do, it's going to give us g of 5 minus g of -2. Now I have to solve for g of 5. And then this guy goes to the left, becomes a positive. Oops. Equals g of -2 plus the integral from -2 to 5 of g prime of x dx. Remember, g prime of x is your graph of f. Okay, so now what's g of -2? We already found that at 0. And what's this guy? Well, it's the integral from -2 to 5. And actually, we already solved that. So we got to figure out the area from -2 to 5, and we already found that. So we got this guy cancels, this guy cancels. So now we know that this is 2. So then what is this area? Okay, so this is 2. Remember, what was this area? That was 9 minus 9 pi over 4. Okay, so then 2 plus this is going to give us 11 minus 9 pi over 4. So this guy is 11 minus 9 pi over 4. All right, guys. So hopefully that makes sense. So what's our absolute maximum value? It would be this guy, g of 5. And that makes sense, right? This is 11, that's half, and that's 0. But pretty interesting how they threw that in there. Okay, guys. Last question, part D. It says find the limit, okay, as x approaches 1 of this value here. Okay, well, man, how am I going to do that? Well, what's the first thing your teachers teach you when you're doing limits? Just plug it in. Just plug it in. So what happens when I plug it in? Okay, let's see if I can do it over here. Well, 10 to the 1 is 10, okay? Minus 3 times f prime of 1. All right, so f prime of 1, and then on the bottom I have f of 1 minus the arctan, okay, of 1, okay? All right, well, that's not too bad. What's f prime of 1? Okay, so this is the graph of f. So at x equals 1, it's here. What is the answer? 1? No. Remember, this is the graph of f. They want f prime of 1. So at x equals 1, we have to actually look at the slope of this line. At x equals, what's the slope of this line? Well, if you start here, you go up 2. Well, let's go 1, 2, 3, 4. 1, 2. So up 4, to the right 2. 4 divided by 2, the slope is 2. Okay, so you see how they asked that question? You have to analyze the graph. So it's 10 minus 3 times 2. Okay, because the slope is 2. So now here, what is f of 1? See, that's a different question, right? What's f of 1? So at x equals 1, see, this is the graph of f. So at x equals 1, what's the value? Oh, it's 1. Okay, that makes sense. 1 minus. And then what about this guy? What's arctan of 1? Well, basically you're looking for the angle, guys. So you're looking for the angle. So where is tangent equal to 1? Well, it's at two places, at pi over 4 and at 5 pi over 4. All right. But because we're talking about the location in the first quadrant, we're going to be using pi over 4. All right. Now, if they throw in those, it's just going to be a simple, trig ratio that you have to evaluate, but nothing very difficult. Okay. So then this would be your answer. Okay, guys. So hopefully that made sense, guys. I'm sorry it's all over the place, but the strategies that we're talking about, you know what? Part A, like, man, how do I do it? You draw a picture, right? So it's more visual for you. What about letter B? You know what? You split up the integral, right? And then maximum value, all right? Your fundamental theorem, all right? And goes back to all of this that we're doing. But I want to go ahead and do one more from 2019 as well. And this one's just kind of like an oddball, right? It's not a what do you call it? A rate accumulation. It's not a graph analysis, nothing like that. It's just kind of like an oddball, which I wouldn't think that they're gonna give you something like this, but I mean, you never know, so let's go ahead and analyze this one. Just kind of go through it. The first part, that you have functions f, g, and h are twice differentiable functions. Okay, g of 2 is equal to h of 2, which is equal to 4. Okay, and then it says the line y equals 4 plus 2/3 of x minus 2 is tangent to both the graphs. Tangent. That tells me right away it's a derivative, or it gives me the derivative. Is tangent to both the graph of g at x equals 2 and the graph of h at x equals 2. It says find h prime of 2. How do I do that, right? Well, think about it. This line is tangent to both. This line is tangent to this guy. What is a tangent line? The tangent line gives me the derivative at a particular point. This line gives me the slope or the derivative of h at x equals 2. So what's a slope at x equals 2 for h? What's a derivative of h at x equals 2? It's this guy. It's 2/3. Because see, this guy is tangent at exactly that point. What does tangent mean? It means a derivative right at that point. So h prime of 2 is actually the 2/3. The slope is right there, 2/3. And that's it, guys. You don't have to give any justification, any reasoning. That's it. Just put the answer. You're done. And that gives you 1 point. All right. So you can see how they really want you to understand that conceptual understanding. So part B. Okay, let's go ahead and do part B. Let a be the function given by a of x and is equal to this guy, write the expression for a prime. Okay, and you notice, what are they asking us to do? The product rule, So the first function, 3x cubed times the derivative of the second, plus the second times the derivative of the first, which would be 9x squared. Okay. Now, I know some of you guys do it backward. It doesn't really matter. That's just how I remember it. It doesn't matter because, right, it's positive. Addition is commutative. So now all I have to do is plug in a prime of 2. All right, so 3, plug in the 2, and we'll do that right before we start doing our mental math, plus h of 2 times 9, 2 squared. All right, so what do we know? We know 2 cubed is 8, 8 times 3 is 24. All right, and then h prime of 2. Well, what is h prime of 2? Okay. Oh, hey, look at that. We already found it. 2/3. Plus, what is h of 2? Well, they give it to us, don't they? H of 2 is equal to 4. Okay, nice. 4 times. And then this is 2 squared is 4 times 9 is 36. Nice. So 24 divided by 3 is 8. 8 times 2 is 16. Now, honestly, if you guys want to leave like this, they should give you all the points. Okay, and then plus 4 times 36, that's 120 and 24, 144. Okay, so a prime of 2, you should get 160. All right, guys. But again, if you leave it like that, you should get all the points, guys. There, because look at, you showed this, you showed this, you showed this. Okay, everything after this is just arithmetic. So you should be good. So we've done A, we've done B. Now let's go ahead and do C. And this guy is an interesting animal. All right. Part C says the function h satisfies h of x given this equation. X cannot be equal to 2. It is known that the limit as x approaches 2 of h of x can be evaluated using L'Hopital's rule. Interesting. Okay. Use the limit as x approaches 2 of h of x to find f of 2 and f prime of 2. Show the work that leads to your answers. Cool. All right. Well, what are the key words there? Where do I start, right? It's like, man. Well, L'Hopital, I know L'Hopital's rule. That's fundamental, right? That means you take the derivative on the top and the derivative on the bottom. Well, when do we use L'Hopital's rule? Remember, we use L'Hopital's rule when it's indeterminate, right? 0 over 0 or infinity over infinity. Okay, so let me go ahead and do that. So you would go ahead and do the limit as x approaches 2 of h of x. Okay, and you would take the derivative. This guy would become 2x. This guy, the derivative of 1 becomes 0. Now you have that negative. Just kind of put the negative out, hide it, do your power rule. 3 times f of x becomes to the second power times f prime of x. And then just go put that negative back in there. All right. So we have this here. Okay. I did L'Hopital's rule. Okay, so now what do I do? Now I got to figure out what f of x and f prime of x. Well, how am I going to do that, right? Well, we know a couple of things. We know f, g, and h are twice differentiable, so they are continuous. Okay, now here's what I want you to think about. L'Hopital's, when do we use L'Hopital's rule? The only time we use L'Hopital's rule is when it's indeterminate, right? 0 over 0. So this means that the guy on top would be 0 and the guy on the bottom would be 0. So that means we would have this, right? And I'm just going to do it the long way just so you guys can understand, because that's the key thing here is understanding. Okay, so the limit as x approaches 2 of h of x. Okay, that means that the limit on the top of x squared minus 4, and I forgot, I put the x here, and then take the limit on the top of 1 minus f of x to the third. Okay, that should give you 0 on the top, 0 on the bottom. Does that make sense? Right, because the only time we're using L'Hopital's rule is when it's indeterminate. So that means we're taking the limit on the top, we get a 0. We take the limit on the bottom, we get a 0. So I need to find f of x. I need this guy. Okay, so check it out. The limit as x approaches 2 of 1 minus f of x, okay, to the third power equals 0. That's what that means. Why? Definition of L'Hopital's rule, right? Because look, it has to be indeterminate. So what does that mean? Well, the only way, therefore, the only way this guy's going to equal to 0 is if this is equal to what? 1. That's right. There it is. So what did I have to do? I had to use the understanding of L'Hopital's rule that is indeterminate to be able to analyze this and say, you know what? The denominator has to be also equal to 0, the limit, and then I can go ahead and understand that f of x has to equal to 1. So now this guy is going to be equal to 1. So the limit as x approaches 2 of h of x is equal to 2x negative 3 times 1 squared times f prime of x. But then we need one other part. Well, how am I going to solve this, right? Well, remember, what did they tell you? Okay. What did they tell you? They told us that h of 2 is equal to 4. Okay. Well, then how do I do a limit? Remember, you just plug it in right here. So the limit as x approaches 2 of h of 2, that's going to equal to 4, right? Because what? It tells me right there h of 2 is equal to 4. All right. And what else am I doing? I'm plugging in 2 into my x's. So 2 times 2 is 4. So then negative 3 times 1 squared times f prime of x. Well, from here I can go ahead and solve it. So I have 4 is equal to 4. 1 squared is 1 times negative 3 is negative 3. Okay. And then negative 3 times f prime of x. Well, from here I can solve it. Go ahead and cross multiply. You get negative 12. Actually, let's multiply the whole thing. Negative 12 f prime of x is equal to 4 divided by negative 12. So that means f prime of x is equal to 4 twelves or negative 1/3. All right, guys. But you see how we did that? Okay. Man, really, really deep conceptual understanding for this question. But what do you notice? Okay, L'Hopital's rule. Well, that goes when 0 is 0 over 0. And then so you have to work your way back to say, okay, well, that means this limit as x approaches 2 has to equal to 0. When you take a look at it closely, you say, well, the only way that can happen is f of x equals 1. All right, I was able to find that. And if you go back, well, the limit as x approaches 2 of h of x, well, they tell me as x approaches 2, h of 2 is 4. So I can be able to do that. And of course, x approaches 2, I plug it in here and I plug it in here, and then I can go ahead and evaluate it. And that big boy was 4 points. Okay, so very, very interesting question. Okay, but let's go ahead and finish it off. Go ahead and do letter D. All right, letter D. It is known that g of x is less than or equal to h of x between 1 and 3. Let k be a function satisfying g of x is less than or equal to k of x, which is less than h of x. For the open interval between 1 and 3, is k continuous at x equals 2? Man, that's confusing, isn't it? So here's what we're going to do. We're going to do the same thing we did with the other problem. We're going to make a picture. Yeah. So what does this mean? G of x is less than or equal to h of x. Okay. That means for the open interval between 1 and 3, so let's say 1 is there. Let's say 3 is there. Okay. Let's say I have a function, I don't know, continuous. Okay. How do I know it's continuous? Because in the beginning they tell me f, g, and h are differentiable. So I know g of x is less than h of x. So this is g of x, and I'll just do it over here. H of x is up here. Okay, right? G of x is less than h of x at that particular point. Same thing over here. Cool. So let k be a function that's between g and h. You see that? This means between g and h. Okay. So let me do it in red. I'll just do this again. So this is h. Okay. Between 1, 3. So is k continuous at x equals 2? Justify your answer. Well, if this guy's continuous, excuse me guys, if this guy's continuous and this guy's continuous, and then h is between these two guys, well, then you would say, well, yeah, it's common. But what rule are we going to use? Well, this is actually from the squeeze theorem. You're going to go ahead and it makes sense because, see, this guy's between or squeezed between these two. So if this guy is continuous at x equals 2 and this guy is continuous at x equals 2 and this guy is between them, then it's obvious that it's always going to be continuous as well. Okay, so what you can do is you can write the limit as x approaches 2 of g of x is equal to 2, right? We know that because they tell us, okay? G of 2, okay, h of 2, actually that should be a 4. And then we also know the limit as x approaches 2 of h of 2 is equal to 4, okay? And then we know, and you can just use their verbiage, right? We know that h of x is between, k of x actually is between g and h. So if we know this limit is 4, this limit is 4, and we know that k is between these two, therefore, okay, we could say the limit as x approaches 2 of k of x is equal to 2. Okay, same thing. It's like if a equals b, okay, and then b equals c, that means a has to equal to c. And it just makes common sense, even if you don't use the squeeze theorem, but that's where you get it from. So you would write the limit equals 4, the limit of h, okay, equals 4, okay. And then we say that k is between g and h, okay. So that means this guy has to also equal, keep writing 2, I'm sorry, also 4. All right, guys? And it actually comes from the squeeze theorem. But even if you don't remember the squeeze theorem, it makes common sense. So hopefully you see by writing this out, drawing it out, see, I think that would actually give you some justification. You would actually have to put this as well, because this part D is only worth 1 point. Part C was worth the bulk, which was 4 points. Okay? But hopefully you see by drawing it out, it made more sense. Okay? So hopefully, guys, that helped you guys out. Sorry for the mess, but keep working hard, guys. I know you guys will do great.